Here we've got an example where we're having to find the average gradient, and they've started off by giving us an equation to consider. So f of x, which is mapped onto x squared plus x, that's the notation of that arrow. Exactly the same, it's really just, it's another way of saying f of x equals, okay, equals your x squared plus x. So that's the equation of your parabola, all right? Determine the average gradient. Okay, so now remember, as I said to you in the previous video, average gradient means we are needing to work out the gradient between 2 points on your line, okay? Between. Now, I like this example because it's giving you 3 different average gradients, but it's kind of asking it in 3 different ways. So I quite like that because you need to expect to see them in any one of these ways, okay? So the first one is where we're looking for the gradient between where x is 1 and x is 3. Okay, so that's pretty straightforward. Let's start that one over there. Okay, we have got our x is 1 and we don't know the y value over there. X is 3, but we don't know the y value over there. How are we going to find the y values? Well, we have got this equation, and what we need to do is substitute each of the x values into that equation, and you'll get the y values. Okay, so we're going to work those out. So first things first, we're working out f of 1, all right? If I substitute 1 into each of the x's of your original equation, we're landing up with 2. All right, so that means that my first coordinate point here is 1 and 2. What's the other one? I've got f of 3, and if I substitute 3 into each of the x's of the original equation, that's going to land up giving you 6. Is that right? No, 10. Sorry. Okay, so there we go. That's now going to give you the coordinates of 3 and 10. Right, now that we've got both the coordinate points to find the average gradient, so we say therefore the average gradient, okay, from point A to point B is going to be y1 minus y2 over x1 minus x2. I'm getting 8 over 2, which is giving me 4. So the average gradient of the line, which is slicing through your parabola at the point where x is 1 and x is 3, is an average gradient of 4. Okay. How else can they ask it? Here they said, calculate the average gradient over the interval. Now this is interesting because remember, this over here represents what you call interval notation, okay? And interval notation is telling you between where and where on your x-axis you have a particular function, okay? So that really is just another way of saying where x was -3 and where x is -2, those are the 2 points on the x-axis, and they're wanting to find the gradient between the points. So just like we did in the previous example, we know that the first x value was -3. We didn't know the y value. The second x value was -2, but we didn't know the y value. Okay, so same process. You're going to substitute f of -3 into the original equation. That gets you to a y value of 6. If I substitute -2 into the original equation, that's giving you a y value of 2. Then we say average gradient is the change in y over the change in x. You know what, let's just fill these in. So let's take those unknown y's away, and let's fill in that was 6 and that was 2. So then we say y1 minus y2 over x1 minus a negative, which becomes plus y2, so just remember that. And what do we get? So I'm landing up with a 4 over a -1. So in this case, the average gradient would be a -4. Negative gradient, that's the one pointing down, okay? And then thirdly, okay, this one's quite nice because it's just asking it in a slightly different way, so don't let it throw you, okay? It says find the average gradient between -1 and f of -1 and between 4 and f of 4. Well, just remember that f of -1 is just the y value where x is -1. And f of 4 is just the y value where the x value is 4. So all you're doing is exactly the same thing as before. It's just being given to you in a slightly different way. So you've just got to be able to recognize and interpret that kind of notation so that you don't let it confuse you, okay? Okay, so then that's exactly what we're going to do. So the first thing was we had an x value of -1, but we didn't know the y value. And then we had an x value of 4, but we didn't know the y value. Okay, so just as we did before, we would work out the value of f of -1. And subbing it back into the original equation, here we land up with a y value of 0, okay? And f of 4, if we sub that back into the original, we're landing up with, what are we getting? 4 as well. No, 20, sorry, 20. Okay, right, so now we take change in y over change in x. Let's get our gradient. All right, average gradient is going to be change in y's over change in x. That becomes a plus because obviously minusing a negative will become positive. And that is getting us to 20 over 5, which simplifies to 4. So that also worked out to be a gradient of 4. What do you know, just as a matter of interest, if I took the answer to C and the answer to A, if this gradient over here is 4 and this gradient over here is 4, what could you say about those average gradients? I hope what you're saying to me is that they are parallel. Okay, that's exactly what they would be. Just a little extra point there, but obviously any lines that have the same gradient are always parallel. Okay, right, there we go. I've got some more examples of these to do, so make sure you do them, and then we'll see how we go from there. Well done.